Greetings everyone. This is our project ProCPU, a CPU scheduling simulator designed to help users understand how different scheduling algorithms work through visualization. Starting from the top, this is the main interface of our system where all the interactions takes place. Now moving to this section, this is the process input area. Here the user can enter the process ID or name, arrival time, which indicates when the process enters the system, and the burst time, which is the execution time required by the process. And we also have an optional priority field for priority based scheduling. After entering these values, the user click on add process and the process get added into the list displayed here on the right. As you can see, this section shows all the processes that have been entered. It helps the user to keep track of the data before running the simulation. We also have included the options like load sample data, which automatically fills in the example processes, and clear, which resets everything. This improves usability and saves a lot of time during the testing. Next, moving here, this is the algorithm selection section. The user can choose from different CPU scheduling algorithms like FCFS, SJF, and priority scheduling. In this case, we select one algorithm to proceed with the simulation. Below this, we also display a performance graph, which usually represents how different processes behave in terms of execution. This gives us a quick analytical view before running the simulation. Now, I'll hand it over to my partner, who will explain about the simulation and the output.
Before I move on to this section, first I want to introduce myself. My name is Progress Murao and I'm a BTech student at Lovely Professional University. So this is the simulation area, which is the core part of our project. Here we visualize the execution of processes using a Gantt chart. Each block represents a process and the length of the block corresponds to its base time. The timeline shown here represents how the CPU is allocated over time. Based on the selected algorithm, it changes its order of execution automatically. For example, in shortest job first, the process with the smallest base time is executed first, which helps reduce overall waiting time. We also added interactive controls such as play and pause to control the simulation. Step forward and backward to observe execution step by step, and reset to restart the simulation. These controls make the system more interactive and help users clearly understand how scheduling decisions are made. Along with the visualization, the system also calculates important performance metrics such as the waiting time and turnaround time. These values help in controlling the efficiency of different scheduling algorithms. To conclude our project provides an interactive learning platform, clear visualization of CPU scheduling, and better understanding through real-time simulation. Thank you.
Hi, I am Jitaksh, and let's understand the internal workings of ProCPU. This is the core of ProCPU, the run scheduling algo function. It takes 4 parameters: the algorithm name, the list of processes, the scheduling type, primitive or non-primitive, and the time quantum for round robin. For primitive algorithms, we simply sort the processes by burst time for SJF, by priority for priority scheduling, and by arrival time for first come first serve. Then execute them one by one without interruption. For round robin, we maintain a queue. Each process gets its slice of CPU time equal to the time quantum. If it's not done, then it goes back to the end of the queue. This continues until all processes complete. For primitive SJF, also known as shortest remaining time first, at every single tick of time, we scan all arrived processes and pick the one with the shortest remaining burst. If a newer shortest job arrives mid-execution, it immediately takes over. The generate timeline function converts those results into visual segments, each with a start time and end time, which are then fed directly into the Gantt chart. This is the animation engine. We use request animation frame to advance current time by 0.1 every 100 milliseconds. This drives the entire Gantt chart animation in real time. Instead of re-rendering React components on every frame, which would be very slow, we use imperative DOM refs. Each bar gets its width updated every second directly via set attribute, making the animation smooth and performant. Finally, this is the algorithm recommender. It runs every algorithm on your process set. compares their average waiting times, and automatically tells you which performs best for your specific inputs. Thank you.